Hi, I'm Gary Rubenstein, and I've been through 8 parts of these essential math for kids and parents. They are just my musings on what I think kids should know about math through the different years of schooling. My daughter's in 7th grade, my son is in 4th grade right now, so I've been watching them go through it. So this stuff is sort of fresh in my mind, and yes, I'm a high school teacher, but I've also taught elementary school, and 6th grade, that is. So today's topic is about what I'm just going to call pre-algebra. I start seeing in 6th and 7th grade stuff that counts as algebra. Now, what is algebra? That word, which brings up a lot of bad memories for a lot of people, it's an Arabic word. It comes from an Arabic word, and I believe it means to restore. And I'll explain what algebra actually is. Algebra, some people say, oh, algebra is when math has letters in it. That's actually not, yes, algebra often does have letters in it. But here's what algebra is. Algebra is when you have an unknown thing. Like, for instance, little kids could have it, like question mark plus 1 equals 5. You have this unknown thing, the mystery box. And yes, so you can have a first grader answer this question, and they figure out, oh, the question mark has to be the number 4. How do you know? Because 4 plus 1 equals 5. That student has not actually done algebra officially. If I call it x plus 1 equals 5, and the student says, oh, okay, so that x has to be 4, they've answered the question. They found the number that made the equation true. But algebra is officially when you have an equation and you manipulate that equation by doing things to both sides. And I used to teach this by saying, imagine there's like a seesaw and there's 2 kids sitting on it. And the kids, they weigh the same amount, let's say, and the seesaw is perfectly balanced. So I'd say weight of kid 1 is equal weight of kid 2. Well, these are modern kids who get bored on the seesaw. So if I give them each a TV set, old-fashioned TV set with antennas, if I give it to just one kid, well, it won't be true anymore. It's not balanced. So to make it balanced, I need to give the other kid a TV. So when you add stuff to both sides to turn one equation that was true into another equation that's true, that's when you're doing algebra. If you subtract something from both sides, so now let's say I have 2 kids and they're each holding some kind of toy. So the left and right side are the same weight. So the kid with the toy has the same weight as the other kid. If I subtract away the toy, well, those 2 things aren't equal anymore. So I have to subtract away the toy from the other kid also. And then those 2 things will be equal. So what does this have to do with math? Well, when I say something like x plus 1 equals 5, if we imagine a seesaw with 5 literal 5 1-pound weights, 2, 3, 4, 5 1-pound weights on one side, and on this side there's a mystery box and a 1-pound weight also. And those 2 things are balanced, they're equal. If I subtract 1 from this side, well, the 2 things aren't going to be balanced anymore. Though it's good that the mystery box is all alone, It's not balanced anymore. So I have to subtract away 1 from the other side also. And when I do that, I get a new equation, which is just x equals 4, which is the answer to the question, what was x? But really, it's just another equation, a thing with an equal sign and two sides, but it's such an easy equation, x equals 4. What makes it true? It's like, who's on first? X equals 4, so what's x? It's 4. 4 is the one and only number that makes this equation true. It's also the one and only number that makes this equation true. 4 equals 4 is like a true thing. So some things you do, you get like x minus 3 equals 7. That's a little harder to visualize. The way I would visualize it, I have 7 things on one thing, on one side of the seesaw. And the other one, I have this mystery box. But the mystery box is like incomplete. Let me draw it like, I'll draw like a mystery box, but it'll be a mystery box with, here's a good idea. Yes. Again, I don't plan this all out before I start talking. Here's a mystery box that's like missing. Notice how it has these little red areas that are cut out. So it's a mystery box that's missing 3 pieces. Maybe I should have made them circles. So I don't want to know. I want the mystery box, just the mystery box. Like here, get the mystery box by itself. Well, this mystery box is missing pieces, so I add in those 3 pieces. Well, now this side's going to go down because it's not balanced anymore. It was balanced before I added in those pieces. So I add in 3 pounds to the right-hand side also. When you add to both sides, that's officially like the Arabic word of algebra is when you're adding things to both sides of an equation. So this person is really doing algebra. Person who looks at it and says, I think it's 10, that's not, they are solving for x, but they're not doing algebra unless they're doing stuff to both sides of the equation. So you can subtract both things from both sides of an equation, or you can add both things to both sides of an equation. You might be thinking that, well, that's algebra? That's what, my bad memories of my middle school and high school years about? Basically, that's officially what algebra is. Algebra, a course of algebra includes other things. And I'm going to, I have a lot more to say about algebra in this video. Sometimes you get an equation like this. 2x equals 10. So that's saying if I have 2 mystery boxes, that balances out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 weights. Well, I want to know, what about 1 mystery box? Well, you might say, well, I'm going to get rid of one of the mystery boxes. Well, that's fine, like minus x. But the problem is, if I don't know how big the mystery box is, I can't really go much further with that. So the thing to do instead is to divide both things by 2. See, 2 mystery boxes divided by 2 is just 1 mystery box. And 10 divided. So I'm basically taking away half the stuff on the left-hand side, and I'm taking away half the stuff on the right-hand side. And in that way, I've actually done algebra when you divide both sides of the equation by the same thing, in this case divided by 2. So you can add to both sides, subtract both sides. And you could even say, like, if x divided by 2 is equal to 5. To visualize that with my seesaw example, I'd have this kind of like, that's like half of the mystery box. You draw half of a mystery box. Well, you could draw a whole mystery box, cut it in half. And then you can erase half of it. It's not easy to do that. Not with this eraser that I'm dealing with. So half a mystery box equals 5. So what I'd want to do is times it by 2 to sort of double. Now I have a complete mystery box, but I have to double the other side also. And I get x equals 10. Now there's more to algebra than that, but that's the basic idea. You're doing stuff to both sides. Funny example that uses algebra. Something like this. Let's say, yeah, that's fine. With equivalent fractions. Remember how we learned that you can take equivalent fractions and you can take fractions and multiply the top and bottom by the same thing. If I multiply them by 3, I get 3/6. If I multiply them by 4, I get 4/8. I do that forever. So I might want to say, like, what about I say 4/8 is equal to, like, x over 6, something like that. It's not that obvious what the answer is when you see the question written in this way. But this is an algebra question. It can be done with algebra. Without algebra, you might say, oh, well, 4/8 gets reduced to 1/2, and 1/2 is, I have to multiply top and bottom by 3. You could do it without algebra. But with algebra, you would want to multiply both sides by something. And the thing I can multiply both sides by, I want to make it so there's no more fractions. So if you look at the multiples of 6 and 8, 6, 12, 18, 24, here's the multiples of 8, 8, 16, 24. We say that 24 is the least common multiple of 6 and 8. If you were to multiply both sides by 24, look what would happen. The right side, the 24 over 6 would reduce to 4 over 1. It would be 4x. The left side, well, you could do 24 times 4, get 96 divided by, in fact, I am going to do that. You get 12. And then you can divide both sides by 4, like we did in that other example with a 2x equals 10. Get x equals 6. Something went wrong there because the answer is not 6. So let's see. Again, I do these in one take. 24 times 4. Nothing wrong with that. 24 times 4 is 96. It must have been 96 divided by 8. Oh, I divided by 2 instead of 4 here. I got 3 equals x. Well, I made a mess of that. Let me go back to that and show you something else about it. I want to multiply both sides by something so that there's not going to be any of these denominators anymore. One thing that would definitely work is 6 times 8 equals 48. See, if I do times 48 to both sides, use that dot instead of the times sign. On the right side, it becomes 48. I reduce that. 48 over 6 is 8. On the left side, I could do 48 times 4 and then divide by 8. Or I could do 44 divided by 8 and then times 4. I'd rather do that. Then you divide both sides by 8. And you get x equals 3. But what I wanted to show you is there is a sneaky way to get from here to here without dealing with that whole pesky 48 thing. And it's known as cross multiplying. Basically, it's saying if you have an equation like this with two fractions, if you diagonally multiply two of these things together, that's one side of the equation, and diagonally multiply the other two, you get the other side. It's basically the same thing that you would get as if you multiplied both sides by 8 times 6, which is 48, but it gets you there right away. And it's called cross-multiplying, and it's a very common thing to do in math. And getting from here to here, even though cross-multiplying just is seems like a fancy trick, it counts as algebra, because really you multiply both sides by 48, which is an algebra thing. And then we finish this question by dividing both sides by 8, which is also an algebra thing. Anyway, cross-multiplying comes in handy because when you do what are called proportions, we say 5, packs of Pokemon cards cost, let's just say it costs $4, I'll say cost $8. How much would 7 packs cost? And we can do a little proportion like this. 5 packs to $8 as 7 packs to I don't know how many dollars. Now, if it was 10 packs, well, you wouldn't need algebra. You could just say, okay, I'll just turn this fraction into an equivalent fraction by multiplying both sides by 2. But it's not that obvious. What do I multiply 5 by to get 7? So this so-called cross-multiplying, which, like I said, is really a hidden type of algebra. 5x, 8 times 7 is 56. Divide, I'll use this division symbol. On the side, I'll do 56 divided by 5. I'll use decimal remainders here. Five into 10 is 2. So the answer would be $11.20. See, it's not that obvious of a question. I never even worked on this question before. I mean, there's other ways. You don't need algebra for these. You could answer this question by, oh wait, hold on a sec. My pen stopped working. You actually don't. You could answer this question some other way. You could say, well, if 5 packs cost $8, then 1 pack is whatever 8 divided by 5 is. 1, 3. So it's $1.60 for 1 pack. Then you can multiply $1.60 times 7. I'll just call it 1.6 times 7. Whoops. What happened there? What did happen there? Ah, yes, 6 times 7 is 42. 1 times 7 is 7. See, we get the same answer. So it's like, you don't really need this cross-multiplying algebra thing, because we could do it this way before you learn like cross-multiplying algebra. But cross-multiplying is like a pretty famous thing. With cross-multiplying, you can do percent questions. If I say, 20 out of 25, is how many, is what percent? Percent problems always have 100 down here. Before I start cross-multiplying, I like to reduce my fractions. 5x equals 400. X equals, divide both sides by 5. Any percent question can be set up this way. what's 30% of 80? You can go like this. $30 is to 100 is what is 80. So 30% of 80 is going to be less than 30 because 80 is less than 100. Again, I like to simplify my fraction, make it 3/10. Now I can cross multiply. 240 equals 10x. Divide both sides by 10. We actually finally have the opportunity to do the third type of percent question, which is, it's a weird question. I left it off of the percents thing altogether. It's kind of like this. 50. No. Hold on, let me get my question right. Not 50 is what percent of 80, because that's just a 50 out of 80 thing. Yes, 50 is 20% of what number? That's the third type of percent question. Like, it's something bigger than 50, but like it's some large number, but what is it? Well, with proportions and cross multiplying, you end up putting the 50 up here in the top left. So basically there's three places the x could go. In this case, it's up there. Now I like to reduce, and I can actually reduce more to 1/5. Now I can cross multiply 1x equals 250, or x equals 250. So that's cross multiplying. That's an important part of algebra. Sometimes you have these questions that are like 5x, there's extra stuff, 5x plus 70 equals 150. Yes, I could imagine the seesaw thing. There's like 5 of these x's. And there's 70 of these little things. And there's 150 on this side. It's a two-step algebra problem. It's best, eventually we're going to divide by 5, but it would be better if we first take away the 70 from both sides. So now this is all gone, and a lot of this stuff is gone also. And then you divide by 5. X equals 16. The reason I mention this question is some people say that algebra is needed for like business and things like that. Imagine I said, I think I want to do one with minus. So here's one with minus. 5x minus 200 equals 60. So the way we do this with algebra is we start by adding the 200 to both sides. Then I divide both sides by 5 on the side. This stuff can seem pretty dry, but there is like a word problem that we can do. Suppose that you own a store that sells Pokemon cards. That's all I can think of right now. My son loves those. And you pay $200 a week rent. And you profit $5 each pack. And the question is, how many packs do I have to sell to profit $60? And you don't need algebra for that. You might say, okay, I'm going to be paying $200 rent, so to get $60 profit, I'm going to need to bring in $260. The $200 to pay the rent plus the $60 for my profit. Then you say, well, okay, how many packs is that? Well, I have to divide by 5 to get 52. So I wouldn't need algebra to answer that question, but just so you know, and sometimes we try to tell kids, oh, you need algebra because how would you do this without algebra? Well, I would do it by subtracting and then by dividing. That's how you would answer this question. But you could set up an equation where x is the number of packs and 5 times it is going to be my profit for the packs, minus 200, which is my rent. I want it to equal 60. If you can turn it into that equation, and you know to add 200 to both sides, 5x equals 260, and let's divide both sides by 5, well, you get the same answer. You didn't need algebra. You subtract and you divide, which are the same 2 steps you did in solving the algebra problem. So I just wanted to mention that. You could get through life with never learning algebra. In that, I mean, there are in science you're going to need, you need algebra to do things in science, but algebra is just a way of telling you how to find an unknown thing, what steps to do, like when to subtract, should I subtract, should I divide? Those steps are things that you probably know how to do even without algebra, like this Pokemon pack with the $200 rent thing. That's not to say algebra is not a good thing, just saying that it's a bit of a lie that you need algebra, in life. Nonetheless, I think it's good that we teach students algebra. Otherwise, how would they know if they liked it or if they were good at it and liked it? And how would they go on, people who go on into science, we don't want to limit who can go on to science. So you hear people say algebra for all. I do think that after learning the basics of math, learning a little bit of algebra is a good thing. And in this video, I showed you just the gist of what I think of, like what is algebra. Now, you might say, well, what about all that other stuff? That's coming in future videos. But for now, this is the idea of what algebra is. And I want algebra in less than 30 minutes, at least the literal definition of what algebra means. Plenty of topics that students learn in an algebra course to apply the algebra. That hasn't been covered in 30 minutes. Keep watching.